And that's going to be the same thing as taking the limit as x approaches 5 of x times the limit as x approaches 5 of g of x, okay? And now we already know this second one here that was given, that's 6, okay? The first limit, we're just plugging in 5 for x, okay? That's all that's there is x. So this one's going to be 5 and then times your g of x, which was given to us as 6. So that'll be 30. Okay? All right. So when we have been finding limits, sometimes the limit was the same as the value. When this happens, direct substitution will work. Okay? For example, if we wanted to find the limit as x approaches 2 of x squared, it would be 4 because we're just directly substituting in 2 and getting 4. Okay? However, if substitution does not work, you must try other methods. So if you look at this example, if you plugged in -2, you would get 0 over 0 actually, okay? Now, you would get 0 over 0 or undefined. Okay, so that does not mean the limit doesn't exist. That is not deity, which I know some of you were saying, and that's okay, but now that we're moving on, we're going to find other ways to still evaluate the limit. Typically, this means there's a hole in the graph at that value. And as you know, you can still have a limit with a hole, okay? So, when this happens, we need to try a few algebra techniques. Let me scroll to that, okay? Either factoring, conjugate multiplication, complex fractions, or trig identities. And today we're really just gonna do factoring, okay? So, let's look at this next problem, which is actually the same limit on that front page. Okay, because this can actually be simplified more. All right, so use factoring to simplify. Then use substitution to evaluate the limit, okay? And so if you're having issues with factoring, you may just need to star this problem or star these problems, and we can talk about it more in class, okay? But if we wanted to factor the numerator here, the denominator we can't. It's x plus 2. There's no way to factor that. There's no GCF there, okay? But the top is a trinomial, so we need to factor into 2 binomials. And how we do that is if you think of your -6, what are 2 numbers that times the -6 but add to, in this case, -1 is the coefficient of x, okay? So 2 numbers that times this -6 and add to -1, that would be 2 and -3, okay? And then when we factor with binomials, you want to have your signs, obviously, so this would factor to, hold on, as it would factor as x plus 2, x minus 3. Okay? So that's equivalent to the top. It's just another way to write it by factoring. Okay? So the denominator doesn't change. It's still x plus 2. We're going to group it up so they look the same. Okay? And then we're going to keep simplifying because these 2 factors cancel. All right, so now all we're left with is the limit as x approaches -2 of x minus 3, okay? And now we can use substitution to figure that out. So we're just going to plug in -2 in for x. Okay, so when we take the limit, we use substitution, and it'll be -2 minus 3, and that equals -5, okay? So if you did not simplify this and just plugged in -2, you would get 0 over 0. All right, that's why it's important to simplify. Common factors cancel out, and then we substitute it in our value at the end. Okay, so let's do a couple more. Example 3. In this case, the denominator is what we can factor and simplify, and that's a difference of squares. So that's x squared minus 1. Technically, that's x squared plus 0x minus 1. So what are two numbers that times to negative 1 and add to 0? 1 and negative 1. Add those up, you'll get 0, right? So our denominator will factor to x plus 1, x minus 1. Okay, so sorry, this is the limit as x approaches 1 of x minus 1 over x plus 1, x minus 1. Okay? And so I'm going to put parentheses around the top binomial because those are going to cancel. Okay, and so we're left with the limit as x approaches 1 of 1 over x plus 1. Okay? And then that's our second step here, is to just plug in 1 for x, just substitute. So if you're plugging in 1 for x, you're going to get 1/2 when you evaluate that limit. Okay? All right. So the next one, you know what I forgot to do in the first one is check that if we plugged in 1, were we dividing by 0? 1 minus 1 would have been 0. Yes. Okay. So let's look at example 4. If we plug in 2 for x, are we dividing by 0? No. So this one, we can actually use direct substitution. Okay. So try that first, and I should have the last time, because it may work. Okay. And then you don't have to factor. You can just plug in. All right. So since we're not dividing by 0, breaking any rules of math, we can just plug them in. So that'd be 2 squared plus 5 times 2 plus 6 all over 2 plus 2. Okay, so that'll be 4 plus 10 plus 6, 20 all over 4, and that gives you 5. Okay, so that's kind of a difference between when you do have to factor and when you don't. You do have to factor when you're dividing by 0. Okay, 2 more, and we're going to actually save conjugate multiplication for the next lesson. Okay, so you'll see that show up on the next notes. All right, let's practice this. Actually plugging in 1 first. And as you can see, yes, we would divide by 0. Okay, now for this actual problem, we have the top and the bottom, or the numerator and the denominator, are both factorable. So we have to factor both. Okay, and here's a hint. You should have a common factor cancel out. All right, so we just did x squared minus 1. We just factored that, and it was x plus 1 times x minus 1. Okay, and so hopefully on the top, one of those two will be a factor, or you really will have does not exist. Okay, so let's factor, let me get a different color. Let's factor the numerator and figure out what that is. Okay, so I want two numbers that times to negative 6 that add to 5. Okay, so 6 and 1 could somehow give me 5. I want a positive 5, so that's going to be negative 1 and positive 6. Okay, so that's going to factor as x plus 6, x minus 1. That's a very basic, quick explanation of how to factor. Okay, so the x minus 1s will cancel here. All right, and now we can find our limit just by using direct substitution. So this is now the limit as x approaches 1 of x plus 6 over x plus 1. Okay, and so we're just going to plug those in. So let me just get a different color. 1 and 1. Substitute that in. And you should get 7 over 2. All right, one more. If you want to try factoring this by yourself and pausing it, you can. So pause it right now and you can check your answer, or do it with me. Okay, so if I plugged in 0 to the denominator, clearly I would be dividing by 0 because they all have an x. So yes, we have to factor this one. Okay, so the numerator is a little bit different than a trinomial or a perfect squares, like x squared minus 1 was a perfect square. Okay, the top is just GCF. What's in common with both is x. So to factor this, you just have x times 3x plus 1. You just took x out of both groups. Okay? And what's in common with the denominator? Every term also has an x. Okay, so if I take an x out of every group, now we have 3x squared plus 7x plus 2. Okay? So clearly those x's will cancel out. All right, and a good hint is that one of your other factors should be 3x plus 1. Okay, but now we just have to factor that trinomial. All right, so 3x squared plus 7x plus 2, when you factor that, and you can ask for an explanation if you need it, but it should be 3x plus 1 hold on, that would be and x plus 6. Does that work? Nope, x plus 1. Hold on. Let me do that again. Okay, so if you take 3 times 2, so I'll just explain. 3 times 2 is 6, right? So 2 numbers that times to 6 but add to 7 are 6 and 1. Okay? So you need to split the 7 up to 6x and 1x. Okay? So then you have 3x squared plus 6x plus 1x plus 2. And this is not how I usually factor, so it was taking me a bit. But then you group each one up and pull out the common factor. Okay, so what's in common with x and 2 is nothing, but 3x squared and 6x have 3x in common. So take it out and you're going to get x plus 2, and then what's in common with this is just a positive 1 because really nothing. X plus 2. Okay, so this would factor as 3x plus 1, x plus 2. Okay. All right, so let me rewrite that to the left, and this is our last problem. All right, so now we're at limit as x approaches 0 of x times 3x plus 1 all over x times 3x plus 1 x plus 2. There we go. All right, so now cancel out your common factors. The x's cancel, the 3x plus 1's cancel, and so we're at limit as x approaches 0 of 1 over x plus 2. Substitute in 0 and you're going to get 1/2. Okay? All right, so circle star anything you have questions on and come to